still use Vue2 syntax using the composition API, and you can develop new components using the Vue2 API. So you don't have to use the composition API. It is also available as an NPM package, and you can use it in any Vue2 project, which is, for example, what we had to do for this project and for this course, and it works without a problem. But why? What is so? And obviously, its goal is to improve on the problems or flaws that the problems and flaws that Vue2 had. So there are three main improvements in this. First, it improves the size and maintainability of components. It also improves code reusability. These 2 points I will explain further. And three, it improves has an improved TypeScript support, which Vue2 had, but it was limited. All right, so the first point is size and maintainability of components. So we all know, we have all worked in this course with Vue and its component, and we know that components usually represent objects that are logically grouped together and are usually used repeatedly. So for example, in our course, we had news items and a news list. And so this news list was filled with components news items. So the news items were reused, and they all contained only what they needed to contain and no extra information. The only problem is, you can see here on the left, this is the typical Vue, the syntax in Vue2, where you have your data, your methods, and your computed options. And these colors are supposed to represent, for example, a feature. And so you implement some data for your feature here, a method for your feature here, and a computed property for your feature here. And you do that 3 times. And here you can still see it, but if your component gets very big, it can look like this. And you then have a lot of blocks of code where you have to jump back and forth to understand what is happening or to maintain it. And so the component idea gets it's kind of broken, as you can't maintain properly this component. So the composition API has a solution, which is a setup method, and it's pretty much the entry point of this API. It is started before the component is created, which means that you don't have any access to this, as the component is not created yet. But you can, for example, here, these functions are defined, or are not defined, but are set up, as the method says. And you can then export them here. And so when you start your component, you have these 3 methods available. You could also, for example, have some properties or data, and you set them up in your setup method. And if you return them, then they are available for your template later. This means that your components can then look like this, as you can order them in logical blocks. So everything that belongs to one feature is together, everything for the second feature is together, and so on. This is one of the bigger things improved here. The second thing is the code reusability. In Vue2, you have the problem that, for example, methods were nested inside individual components. So if you wanted to reuse them, you usually would rewrite them in another component, which again would damage the reusability and readability of your component. And so the composition API, again, with the setup method, allows you to define a function. So the way explained before also works for external functions defined individual classes. So you can then define a function in the feature1.js, import this function, and then add it in your setup method. And again, if you export these two methods, it will be available for your template. So this way you can improve your component even more in only having what you need for the component, and you can then group your logic outside of it. And if more components need these functions, they can be used then more than once without having to rewrite them every time. Exactly. These are the two bigger ones. Oh, I don't know what happened. Oh, and there are also some minor, or not minor things. There are many more. For example, there is now also reactive references, which are short are refs. And so any variable can become a reference. And so you can define a reference here also in your setup method, and you could watch it. And if it's changed, you get notified. And yeah, exactly. There are many improvements, but they're all mainly aimed at this improvement of reusability and maintainability of your code. There are two very good. Oh yeah, and when would you use it? This composition API. Obviously now, if you use Vue 3, it would be very good to just use this API as it's the default. But it's not always, I mean, you don't always need it. It's true. If you're writing with TypeScript, you should use it as the support is way better. If you're writing very large components, for example, in our project, our components were fairly short, so there was no problem using the old syntax, but you could still use it. We did it at the beginning, and it was more readable and it was easier to follow. And yeah, if you have functions that need to be reused, exactly. And there are two very good resources directly from Vue, which are these two at the beginning. And is from there. From there, I got most of the information. They explain step by step why it is better and how to use it. So I would recommend anybody who wants to learn how to use it or who has any questions or whatever to. The first one are videos, and the second one is the official Vue.js. What is it? The guide, and they're very well written and very well thought out. So I would recommend them. And yeah, there are a lot of other things, but this was a short overview of the big changes. And yeah, so thanks for listening.
Thank you very much, Philipp, for your amazing lightning talk. That was very interesting. And just to give you a quick feedback on your time, so I have 3.5 minutes over time. So it was something like 8.5 minutes.
Oh.
No problem here, but we're training for situations like, for example, a lightning talk at a tech meetup or something. And what happens usually there is that the host is going to interrupt you. Yeah. So the rule set is there actually quite strict. So then he would just start clapping after 5 minutes, and you would be interrupted. And that's the whole idea of these presentations. I know it's really stressful and it's always difficult to get a feeling for timing, but that's the whole point of giving those lightning talks, to get some training, you know. So yeah, but great. Maybe you can, if you go to a meetup and repeat the lightning talk there, you can maybe practice it earlier and then try to speed it up a little bit. But that was a great lightning talk, very nice. People are clapping in the public chat. And yeah, so now it's time for questions. Where's the audience? Unmute yourself or write it in the chat. While we're waiting, did you say if it's possible to use to downgrade it somehow? Because we had the experience that some of the libraries are not compatible with Vue 3 yet. So is there a way of writing your own custom code, which would be compatible using the composition API, but still not upgrade yet? Is there a way?
Yeah, I mean, that's what I meant at the beginning with the npm package. And that's what we did. We had to do in the project because we started using Vue 3. But there are some libraries like, I think, Storybook, and we had problems with other ones. So we decided to downgrade to Vue 2 and use this composition MPI package. And it works without problems. So yeah, yeah.
Nice. So what it does is you're still using Vue.js 2, but the library, you can implement your code, throw it against this library. The library will output the old Vue.js components. As soon as you upgrade to Vue 3, you shouldn't have any problems anymore, right? So that's the whole idea. Awesome. No one's writing questions in the chat. Why is that? I'm sometimes assuming, I don't know, public chat has frozen or something if people are not citing anything. So as anyone has questions. Yuri, anything from your side, maybe?
No, I think we're just listening very carefully.
Okay. Well, unless there are any more questions, which doesn't seem so, I think we can start with the lecture. Right. Well then, thank you very much, Philipp. That was an amazing lightning talk. And please send me your slides via direct message on Moodle or email, whatever, so we can upload them to Moodle. Right.
All right. Thank you very much. Thanks.
You're welcome. I'm going to take the presenter in order to switch the slides. And here we go. It's about authentication and authorization today. As you have seen, there's a new homework. Well, let's quickly let's check out the homework. Why not? So there's a new exercise, exercise 4. It was already in the homework draft repository. Now it's published here. It's as you expected about authentication and authorization, and you are going to learn a little bit about JSON Web Tokens. And yeah, I don't know, is there anything to say about it? Target schema has changed a little bit. So in the last target schema, we had the name of the user as the ID. We changed that because probably you want to have a user-defined name, and the ID is best to be generated by the server and shouldn't mutate over time. So it's better to split those two attributes, ID and name. So you have to refactor a little bit. But yeah, anything from your side, Yuri, regarding the new homework exercise?
No, I'm not sure whether you clarified that GraphQL Shield is not necessarily required.
Yeah, I will come to that later. So we are talking about authorization later on the lecture. And for example, I found out, oh, well, I can introduce it right now. So I'm recommending a library, GraphQL Shield, which is using GraphQL middleware and GraphQL. So this is the one that I'm recommending here. And they have recently added a new warning here. The project is unmaintained 2 days ago. You see here, right? So I think it's still a great library. I hope they will find a new maintainer soon. But yeah, maybe it's, I don't know. I think both libraries are just fine. I implement a different solution. They work. I'm happy. So I don't think it's any problem to use it. But yeah. And you don't necessarily need to use them. It's a recommendation. Both they solve a particular problem, that is authorization, and it is possible. In theory, it's possible to implement your own, roll your own, but it's much cleaner and better structured with using that library, because you can have a transparent authorization layer. Is that what you mean, Yuri?
Yeah.
Right, cool. Well, so that's the new homework. Have you seen it? I don't know. And how can I stop sharing my screen? Me here. Anyways, all right. I'm opening the chat to see no one has written anything. Great, cool. So let's continue on with these slides. So we are now at the backend level, and authentication and authorization, or these security responsibilities, are a responsibility of the backend. Why is that so, actually? Does anyone know why would you implement it, for example, let's say in the front end? So authentication authorization is all about who are you logged in, are you able to access this resource? Why wouldn't we put that here in the front end? Do you have an idea? Please write into the chat or unmute yourself, maybe. Someone is writing. Yeah, exactly. Client code can be changed by the client. The front end is running on a device which is not under your control. So if that's, for example, a browser or a mobile application, then this code is shipped directly on the phone of your user. So it's not under your control, and it's very, very insecure to put it here. It is possible, I don't know, to implement certain features also on the client for convenience, but the security comes when you put it into the backend. This is a must, right? Yeah. Okay, no problem. Someone got the question wrong. So this here is under your control. This code runs on your server, and this is the only way to protect certain resources from being accessed by users. Everything which is on the client is or might be insecure. So your access to your data, whatever, should be protected by the backend, and the backend should be one entry point, and you shouldn't have any. So you can put your security there and you're safe. And when we talk about authentication and authorization, we often, those two are often mixed in a way. So I'm going to create a quiz question, start a poll. What I'm going to ask, okay, those authentication and authorization are going together, but have separate responsibilities. So I'm talking about what is the responsibility of authentication? Is it identity or permission? And what I mean by that is, identity is asking the questions, who are you? Whereas permission is asking, are you allowed to request a certain resource? Let it be read access or write access or anything. Does it make sense?
What are you asking for? Authentication or authorization?
Authentication. What is authentication about? Is it about identity, proving, like figuring out who is issuing a particular request, or is it about what is the user allowed to access? Oh, people are taking more time to answer. I'm going to wait a little bit. Now nothing is happening anymore, and there we go. So yes, that's correct. It's about identity. That's something I like to explain in order to get the difference right. So authentication is really just about you get a request by someone on the internet, and then you want to know, okay, to which user this request actually belongs. You can prove this request was issued by a particular user, which is known. And authorization is then, as soon as you know who is the user, what is the user allowed to access? Possible examples could be, you are only allowed to write a post when you're authenticated. You are only allowed to see certain private information of yourself, let's say your email address, if it's your own email address, you're not allowed to see other people's email address, for example. That would be an example of read access, whereas writing posts is obviously write access because it's creating some data. I hope that makes sense. This could also be a nice exam question, difference between authentication and authorization. So yeah, maybe we go to the next slide. We will start with authentication. And what we're going to do in the homework is to implement JSON Web Tokens. So JSON Web Tokens is like industry standard. I'm going to share my screen again. Entire screen. Hello, something is happening. My brother is odd. I don't know what is actually happening, but can you see something? Can you see my screen?
No.
Oh, excellent.
Recently switched to Firefox.
I switched to Firefox and I cannot allow this screen sharing. This sucks.
You try to reload the page?
Now it's connecting, so it has troubles to connect. Or disconnect.
You can also set your permissions on the left. No.
So I'm going to reload. I will be off for a minute. I'm going to use another browser. I'm sorry. Okay, I cannot do anything anymore. My laptop completely crashed. Hello, hello. Yuri, you can still hear me, right?
Yeah, we can. I think I hear you.
Okay, I cannot do anything anymore. I cannot switch from another desktop. I cannot close the tab. Actually, I cannot do anything anymore. I have to push the power off button on my machine. So I will be off.
Then see you in a few minutes.
Okay, I have no idea what was happening. So I'm back. Now with a different browser. I hope this doesn't happen again. I'm going to take the presenter. You can hear me now, right? Good. So what I was going to do, oh yeah, show JSON Web Token, the website. So I hope this works. JSON Web Token. So what is JSON Web Token? Industry standard for representing claims securely between two parties. You can use it for other purposes than authentication, but this is probably the most common one. So a JSON Web Token, actually you can see a JSON Web Token already here, is a piece of text, and you can send it to your server. And this piece of text, it works like an assigned email. You probably all know that. When you have your famous email application, you can set up encrypted emails, and you can also sign an email. So encrypted emails are encrypted. No one can read the text. Signed emails are not encrypted. You can still read the text, but you send along with the message, you send along so-called signature with this, which is like a something like a hash, which encrypted, which hashed the email and encrypted that with a private key, and the receiver can decrypt the signature with or can verify the signature with your public key. And JSON Web Tokens work similar. You have a payload, which you can see here. So just some data. In this case, oh, what's happened? Did I scroll? Oh, it allows scrolling. Interesting. So you have this data here, which is the payload. And the payload is painted in this color here, purple, I hope. And it is in here. And you have the signature here. And the red part is the information about which algorithm is used. You don't believe it, but this is actually just unencrypted data. It's only base 64 encoded. I can show you that this is actually not encrypted. By the way, a nice question in the exam. So I'm going just to use echo, pipe that to base 64 and decrypt that. And you can see that this string here is nothing else than the data that you saw on the website. All right. And same thing with this thing here. You can say echo and do the same thing. And oh, I messed up my clipboard. Sorry for that. It's always the same thing. So on my terminal, I have to say Shift, Control, and C to copy. And everywhere else, just use Control C. And in the browser, Shift, Control, and C will actually open the developers. It's happened to me so often. So just Control C, and here Control Shift and V. All right. And base. There we go. I don't know actually why this is happening, but you can see the data here, right? Right. And the last part is the signature. And the idea is that your server can verify a JSON Web Token based on the signature. So you can just send along some data, which might be, for example, a name of a user. And if the server can successfully verify the JSON Web Token, then the server believes the JSON Web Token is valid. And what we can do here is, for example, they say signature verified because it's like the example signature. But what I could also do is we'll do that later. We'll do that later. So does that make sense for now? Does it make sense for now? Let's make a quick poll. It was just a quick maybe. Start a poll. In the meantime, I'm going to set up my example code. So most people are okay with that so far. You can try it out on JSON Web Token IO. Put any JSON Web token that you like and inspect it. And what I'm going to do now is I have my reference solution for exercise 4 already. And I can, for example, log in to, I have a login mutation, which I do like this, log in, and I have to put in email and password.
You're not sharing anymore.
Oh, thank you very much. So hope you can see something. Where's my browser? There we go. Hope you can see something now.
Yep.
Nice. And I'm going to check out my seed data. So I have some users in my database. I'm going to check that out for a second. Seeds. And I have, for example, a user called Alice with this particular email address. This would seem to be all right. And I get a JSON Web Token. Or maybe I don't. Oh, yeah, right. of course, I have to provide a JSON secret, which is like, I don't know, some super secret 1, 2, 3, 4, and run the server with that. And I get a JSON Web Token. And you can see this, the string is separated with dots. So the dots are the delimiter for the 3 parts of a JSON Web Token. So let's just copy that. And to show you that this JSON Web Token is actually clear text, I can put it right here, and this website doesn't have my secret, and yet this website is able to decrypt the first and the second part. All right. And here you can see what I put into the JSON Web Token. So here's just an ID, and that's it. What is that? I think that stands for issued at. So this is Unix time, I guess. Let us check out the documentation. JSON Web Token calls this a so-called claim. Yeah, this is here explained 3 parts of a JSON Web Token. Great. Header. Okay, the first part is actually called the header. Interesting. Second part is payload. That makes sense. And the payload has so-called claims. Some of them are well defined by the specification. And these are the, I think, the public claims. And one of them is the issued at claim. There we go. Here. And I think this is apparently the only one which is required, which says, okay, when has this JSON Web Token be issued? When was this created? So this was the time when I sent this this login mutation. So if issued at changes, then also this part should change whenever I make a new JSON Web Token. Let's see. And there we go. Every time I click on the play button, I get a new JSON Web Token. That makes sense because I have a new piece of data in the payload. Okay, that's about JSON Web Token. And the signature, this is the third part. This is the most interesting part because this is needed in order to verify that the JSON Web Token is actually valid. I used this particular JSON Web Token secret, passed it to my backend, and with that, I can actually also verify my signature here. This is something you shouldn't do with production secrets, all right? So I used a dummy secret. You should never put the secret in any website on the internet. Please don't do that with actual secrets that you use for production. But now I've put it here, and you can see that the signature is verified. If I put something else, oh, okay, the website changes the JSON Web Token accordingly. So if I put another secret there, then it's changing the JSON Web Token. It's not what I wanted. So random secret, and copy paste the JSON Web Token again to force the website, you have to take my JSON Web Token. And you see invalid signature. All right. So a server is only able to verify JSON Web Token based on a secret. And how the server verifies JSON Web Token is also depending, of course, on the algorithm. This seems to be the default. I used a library called JSON Web Token. JSON Web Token, which is a library for Node.js, and apparently they're using the same algorithm by default. There we go, default algorithm. You can change that, and then you would have to like debug it on this website. You have to change it accordingly, of course. All right, so that about the JSON Web Token, the data that's being exchanged, and now to how it's used in the use case. Maybe let's create another poll right now to see if people are still with me. Are you still with me? Best to increase the zoom in a bit in the terminal in GraphQL Playground. Okay, I'm going to do that. Oh. You can't see that right now because I'm not sharing my screen, but I'm going to increase zoom level. So there's one question. What is the difference between private and public claims? Let's have a look after I publish the polling results. So people seem to be okay. So let's have a look. What are the private and public claims? Actually, I think there are 3 types of claims. Public claims, private claims, and registered claims. Okay, I was messing up public and registered claims. The issued at, what is it? Is it part of the, yeah, oh no. Oh, yeah, it is. So issued at is part of the registered claims, which are given by the specification. And then they have public claims, which can be used, but are still defined. And then you have private claims, which are specific to your own application. So obviously this here is a private claim, because it's depending on my application. It depends on what I want to and what I want to use for the JSON payload. It depends on my use case, my application. I hope that answers the question. Great. I love it that you ask questions. You're helping me a lot to create the lecture in a way that it's for you. Okay, Florian says thanks. Great. So now to the actual use case. I have the actual use case on my slides. So now, after you know how the JSON Web Token works in general, let's say you have some kind of server, which is here, and you have your client, which might be a browser or a mobile application, and the browser wants to log into your application. What you can do is you send, I don't know, email password, and there's a user record which exists on the server. Server encrypts or hashes the password, compares it with the database, and check if it's a valid login. And then the server creates the JSON Web Token and sends this JSON Web Token back to the client. And the client can then use that JSON Web Token for all subsequent requests and pass it along with the request. And then the server knows, the server can verify the JSON Web Token. And if the server verifies the JSON Web Token, the server just believes, all right, cool, this is an authenticated request, because the JSON Web Token is valid, because its signature is valid when I use my secret, and the secret is private. So the secret you just saw on my terminal, which was super secret 1234, that is something that's private to the server, right? No one else gets the secret, and you need the secret in order to verify the signature, and that's where the security is coming from. All right, so a client would only be able to spoof such a JSON Web Token if the client would be in control or would have access to that secret. If you ever expose your secret, for example, by uploading it to this JSON Web Token IO website, then you must change your secret in production, because you don't know who else might have access to that secret anymore. And an attacker could probably spoof a JSON Web Token then. Does that make sense? I'm using a lot of pause these days. Yeah, so the security comes from the secret which is not shared. By all means, check engine control, please. This is something you have to pay attention to in your submission for the homework. All right, so this is the scenario if you have just one server which is taking care of login and all of that. You can see here you can use either symmetric or asymmetric algorithm. The difference is that for a symmetric algorithm, you use the same secret in order to verify and sign the JSON Web Token, right? So that would be symmetric approach. Asymmetric is you have public and private key, and you use the private key to sign the token and use the public key to verify the token. If you do that, then you get an extra flexibility. The extra flexibility looks like that. You can actually have one, like you have kind of microservices, and one service is responsibility for authentication, whereas all other services are just using that authentication data, but are not responsible anymore for that. So for example, you have a third party, for example, a service like Auth0, which became famous using JSON Web Token. And the service is taking care of all authentication related features like, I don't know, login, sign up, send reset password, or whatever, and all of that fancy features. And only the service which is responsible to sign the token, create the token, is knowing the private password. So here you're using an asymmetric algorithm, and you have a private secret, private key, and it's being used to create this token. A public key can be used to verify the token. The public key can be shared across all servers who need to verify the token, and those services don't need access to the private key anymore. So you don't like share the secret across all services, which would be a severe security issue, but you can, these servers just need to know the public key in order to decrypt it, in order to verify the signature.
There's one question in the chat.
Yeah.
Whether a running server always has to have the same secret, or whether it can be also maybe changed periodically.
That's an awesome question. So you can change the JSON Web Token. Well, let's answer the question first like that. So it should, the default would be the running server uses always the same secret. It's not changing it periodically. I'm now thinking about the symmetric approach, so this one here, right? So if the server is issuing JSON Web Tokens happily and using the same secret, you can verify those tokens. But what happens if you change the token suddenly? All JSON Web Tokens which have been issued earlier cannot be verified anymore because they are now tried to be verified with a new secret. So those JSON Web Tokens immediately get invalidated. And that you do that, you change the secret when you expose your secret by accident, right? Because you want to invalidate all JSON Web Tokens which are out there. Does that make sense? That's a great question, by the way. And what would happen with this scenario? I mean, you would change the secret here, then also the public key doesn't match anymore, and you have to update the public key on all services in order to make it possible for new JSON Web Tokens to be created. But yeah, all the previous JSON Web Tokens would be invalidated. It usually stays. Yes. It's like you have an account and you want to change your password from time to time. Why not? All right, I think this question is answered. And by the way, this is already working code that you can copy and paste into your exercise if you want. How does it relate to GraphQL now? You know, there's this context function that we learned about in last lecture. And context returns an object which is available to all resolvers and usually has information which are valid for the entire execution, which are interesting or important to every resolver, and which are valid for the entire request. And authentication information is, of course, valid for the entire request. So the idea is that you have a so-called bearer token. A bearer token is nothing else but a specification that you send information about your that you send authentication information in your HTTP header, in a particular authorization header. So if you have a context function which gets the request header somehow, which is the default if you just use apolloserver, then you can look for such an authorization token. The authorization token usually is just the BIRA, the authorization header, sorry. The BIRA token specifies that the authorization header has just a string which starts with BIRA, then a space, and then something. And this something would then be your JSON Web Token. And then you can, for example, start to verify the JSON Web Token with your secret. Of course, it needs the JSON Web Token secret. And then either you are able to verify it, and then you return the decoded payload, or you do nothing, right? If you're not able to verify the JSON Web Token, it's invalid, and authenticated user doesn't exist. You're like a guest user, let's say. So that was the proper implementation for authentication. So far, so good. So that is all you need to know about authentication, basically. I see a lot of people typing. I don't know whether I should make a break, wait for people to write the messages. Otherwise, we go to the next section, which would be authorization. You just not log in again if the server secret is changed. I don't get this question. Can you please explain this a little bit? Who is going to log in, the administrator or a user? Yeah, well, what you would see is that you have some session data. For example, in your browser, you have the JSON Web Token in your headers, and you have some session data, and then you try to go to any page, which you should be able to access if you're logged in, and then you get, oh, you're logged out, and you have to re-log in again. That would be the behavior that you would see as an end user. Right? I mean, it also depends on the front end. The front end should point you to the login route again if an authentication error happens. If you misimplemented this, then I don't know what happens. Then you just get a big arrow sign or something. But the behavior that you would usually see is you make one request to the server, you get something back like, oh, you're not authenticated, and you get redirected to the login route where you see this login window, and you have to re-log in again, get a new JSON Web Token, and all is well. All right. Okay, cool. So that is all you need to know about authentication. Now to authorization, which is different because now we know who is the user already. And we want to know what should an authenticated user be allowed to access. For example, also certain applications have a role model. So you have different roles depending on if you're an administrator, you're a moderator, or you're a normal user. And those type of roles have different permissions, obviously, right? So you're not allowed to, I don't know, disable another user. That is only allowed to an administrator. You're not allowed to disable, I don't know, a comment. That's only allowed to a moderator, things like that. And this is the first slide of authorization, and I put it there because I'm going to suggest you this Graphql Shield library, which is based on another library, which is called Graphql Middleware. So let's check out Graphql Middleware. This is a screenshot, and it's come from Graphql Middleware on GitHub, and developed by Prisma. And they have an office in Berlin, by the way. And I think they're also looking for developers. And you can see that here. So the middleware is a software pattern which has different meanings depending on the use case. So I'm talking here about the middleware as defined by Express. So the Express middleware is implementing something like a pipeline, which is passed to every middleware in succession. And GraphQL middleware works in the same way. They have this onion principle. Each middleware is being called before and after the resolver. So here, that's our actual resolver. And you have two middlewares. And if you configure the middleware in this manner, this means first comes log input. This is the outmost middleware. Then comes log result. Then execution is passed to the actual resolver. And then it goes all the way up again. I'm not going to explain this in detail. I would say have a look into this. Have a look into this particular code, especially into this logging. And just try to imagine that you've wrapped your resolvers with arbitrary code.
May I ask a question?
Yes.
Are you sure that we can use this code you just showed as is? Because I think they don't use the classic GraphQL Apollo, but GraphQL Yoga.
Yeah. apolloserver was heavily inspired, the new versions of apolloserver, by GraphQL Yoga. This was like a library for easily prototyping. They have a documentation further down.
The standalone usage is, I think,
usage, yes. So
the stuff that most people should look at.
Yeah, exactly. So if you want to use it, by the way, you don't necessarily have to use it for the homework, but if you want, you can use it like that. So you have those GraphQL middlewares, and you make executable schema, and then you plug it into your Apollo server at some point. I think this schema, you can plug schema into Apollo server.
Yeah, it's exactly like that. It's just not listed here.
Yeah, I don't like tutorials which don't have all the information required in it. You started with Apollo server. So where you create the instance of Apollo server, instead of type defs and resolvers, you can put in a schema, and the schema would be that. Right? You can use that entire code and then plug this schema into your Apollo server, and magic will work. So this is a middleware, and next up is GraphQL Shield, which is a library which builds on top of those middlewares. Okay, let's have a look first into the GitHub repository. So as I said, GraphQL builds on GraphQL Shield, builds on GraphQL middleware. So here's the repository, and GraphQL Shield is like a very transparent permission middleware where you can see immediately the permission matrix, you would say, right? So you have a resolver map. You know that already. Query, mutation, you all know that. In your case, it would mean users, you have right, and maybe you even have type resolvers. And on the right side, you plug in certain functions which are defining the permissions. Or someone said I should increase the font size. So this is now important for you to see. So this here, you have certain rules defined by a GraphQL Shield. They're coming from there, and or not, Boolean operators. And they can take any function and can build a nice, very expressive permission matrix with that. And is authenticated is a rule which says in the context, so CTX is an abbreviation apparently for the context. You see this has the same signature as any resolver. You know parent, you know args, you know context already. And if you have in your context, you have your authenticated user, which they call just user here. And if that's not null, then you're authenticated, right? And since this is a middleware, the middleware is being called before before you pass execution to the actual resolver. So if you have write post resolver, and you have a middleware which says for write post, I have a rule is authenticated, then this authenticated will be called first. And if this rule doesn't apply, then the server immediately sends you an authorization error and does not pass execution to the resolver, right? So you check this rule first, and if that's okay, then the actual resolver is being called, and if not, you get this authorization error. And for most write access or mutations, this is what you want. So I would suggest the respective rule on the mutation before the execution is actually passed to the actual resolver. Things are different if you want to, for example, make an authorization for read access. Let's say you have, in our use case, you have a user, and the user has some information like email, and you want to make sure email is only readable by the user itself. Then you can, for example, check if, I don't know, is your own or something. You can create a new role, this is my own, and then you can check if the resolved user, which is that then parent, if that's actually the same as the user who's doing the request. And only then you're allowed to see email. And then you would plug in the email resolver similar as a type resolver, right? This might be confusing for you first. Have a look into this and play with it. Let's have a look maybe into the slides. I think I prepared something. So yeah, I have some examples with Graphql Shield here because I want to show you how we can now use your functional programming skills that you learned in Vue.js homework for GraphQL Shield as well. Because the API, how GraphQL Shield is built, is using functional programming heavily. You can see this is authenticated rule here, which is a function call of a function which takes another function as input, right? So it looks really nice, but what's actually happening, if you look closely, so you have the rule, which must be a function which is having those parentheses here, and then you have another parentheses, which is going down here. And then you have this thing. And let's have a look into this a little bit closer. So this is the first method call. This is being executed immediately. It only means that this is like another feature of GraphQL Shield, so it has some caching. Cache contextual means this rule only depends on the context. So is authenticated only depends on the context, because it's, if you use JSON Web Token and you decrypt the user there, then you have all the information you need, and you don't need to check the parent, for example, or the args. It only depends on the context. There are other cache thingies like strict, which would only cache if the parent doesn't have changed, right? So this is just setting up something. It's just telling GraphQL Shield, okay, the following rule only can be cached based on changes to the context. So if the context is the same, then I can take it from the cache and speed things up. So this is the first method call, and it is being called immediately because you have those parentheses here. And since you see that there's another parentheses, you can already see that whatever the return value is, this must be another function, because otherwise you couldn't call the function with parentheses. All right, this is the second method call. And then inside the parentheses, we have yet another function, because you can see the arrow function here. So it's taking a function as input. And this is actually our own implementation of what it means to be is authenticated, right? Is authenticated applies if we have a current user in our data sources, for example. And we cast that to a Boolean, but yeah. So that reads our current user, and if that's something, then we are authenticated. I hope that makes sense. And one last but not least, this is just is authenticated, which you define somewhere, and we can plug this, of course, into our default export, right? Which is having the permission matrix then. So this is a function yet again, has the same signature as a GraphQL middleware, and we plug that into add fruit to basket, right? So functions over functions over functions, and so on. Are you okay with that so far? 9 messages in the public chat. Wow, there's a lot for me to read. You're breaking up. Oh, sorry. Still sounds like someone from the 1920s called. Where you usually define those rules? Is this a separate file, or you'd add it to the type defs or resolvers? It is a separate file. That's how middlewares work. So we have your middlewares, every middleware, for example, defined in a file, and then you load those middlewares, and then you define an execution order. So which middleware should be called first, like the outmost layer of the onion, and then the second middleware, another layer, third middleware, another layer, and so on, until you reach the resolver. The resolver returns something, and then all the middlewares are being executed in the same order. And I would, for example, put the permission very far outside, so you can immediately send an authorization error. For example, if you're not authenticated, you're trying to access a resolver where you don't have permissions for. Yeah, there's this called apply middleware, which like applies the middlewares to your resolvers. They take or your schema and they need to pass like execution context to those resolvers. All right. So far, so good. There are some do's and don'ts. I think we already talked about it. Shield has a fallback rule, which you can see here. So this means everything which I didn't explicitly whitelist, deny, send an authorization error for everything which I didn't explicitly mention, which is nice, which is a best practice. And you should authorize write access. I mean, put the rules for write access into your top-level query and top-level mutation, which you can see here. Right? Whereas if you have put them in your type resolvers, like here, for example, wherever your server returns a user, and if the email is requested by the client of a user, doesn't matter where, any kind of resolver, if one of your resolvers returns an array of users or a single user, and the client requests the email, always make sure that the client is either the same user, or in this case, an admin user as well. Maybe the admin user has also permissions to see other users' email addresses, for example, in order to contact them via mail. Okay, people are making fun of the chat. And that's it for this slide set. Cool, nice. Any questions related to authentication authorization? I think this should be enough for you to get up and running with JSON Web Tokens, and if you want, also add Graphql Shield. No one is typing. I cannot hear anyone, and so I think you're okay. Have a look into the slides, and then I have still some time to talk about promises. So we're going to do a live demo. While I was reviewing the homework, I could see that you still struggle with promises, and I can totally understand that because we didn't talk about JavaScript promises so far. I will suggest to you to read carefully the Mozilla documentation about promises and async await functions. Where did we get in touch with those? when you, for example, write tests and you had in the first and second exercise, you had to wait for your component wrapper to render the HTML code that you were asserting, that you were then checking, right? That was one example where we got in touch with promises. Same with async await. You probably have used, or I was suggesting you should use await for, where am I? JavaScript info. No, that's not where I want to be. Async await developer Mozilla, right? So I was suggesting await to use that in your tests. And we will quickly talk about promises in JavaScript. This is an advanced topic, and I will not be able to explain promises to you within the remaining 30 minutes, so really have a look into these. In theory, promises is a way of JavaScript to do asynchronous execution of code. Asynchronous means code is executed and you don't wait for, let's say, the return value of a particular function call, and you do something else in the meantime. This is very important in the internet world because you often have to wait, for example, for an HTTP request to finish, and you don't want to block the entire site or block the entire server just because, there's something that's taking considerable time. You don't want to execute your code synchronously because of performance. And a promise is just JavaScript's way of implementing that. A promise is a thing, and promise can be in a couple of states. It can be pending, which means the promise is currently being processed, or it can be settled, and it's either fulfilled or rejected. I don't know what this diagram means, but these are the two states: pending, fulfilled, and rejected. Fulfilled means the promise was successful, and rejected means the opposite. And you can, for example, do some error handling then. Let's see, maybe let's do some live coding with a promise. What I'm going to do now is to try to promisify something in JavaScript which doesn't return promises. And the default example is always set timeout. So set timeout executes something after a timeout. This is milliseconds. So in a quarter of a second, you see success. Maybe I don't know what they're doing with this. They lock it. Okay. But set timeout it has a callback. So this here, the first input argument of set timeout function. This is the callback that should be executed, and this is like the timeout itself, like in milliseconds, in integers. So what we can do is we can create a promise and wait for the timeout before we do anything else. I'm going to improve font size of my editor. So I'm going to close this for a second and just, randomly add a file here. So example, promise demo. And I'm going to say set time. Okay, just copy paste this into this here and say console log success. When I run this, the await comment, let's save this file. Folder. Yeah, so no promise demo. You can see the small delay. Maybe I should increase that to 2 seconds. So run this file and then success, which is nice. So Node.js is waiting for all time to be finished. Node.js is doing, apparently you have some kind of event loop, and the node process will only terminate when all events have been processed. So that is after all timeouts have been finished, which is okay if the set timeouts is the only thing you do in this program. But what happens if you do something else, like you log, for example, hello, then what happens is maybe you want to, when you want to write hello and then world after a timeout. Obviously, you could do something like that. Fine. But what if you want to write hello first and after 2 seconds, world? What happens now is that you see hello first. Yeah, I missed. I did it the wrong way in order to show you the difference. Yeah, so now I have mixed it up. I have world and hello. And what I could do if I want to use this promise API is to create a promise and then, for example, this promise. All right. So first of all, do you see the problem here? You have some I don't know. You don't. Your goal is not to put everything to one callback, because if you have callback over callback over callback, then you probably get into the callback hell, and you want to have a nice sequential execution of your program. And does it make sense so far? What the problem is? I didn't publish the polling results. Oops. I think I confused quite a couple of people.
Maybe I didn't see it properly, but for me it looks like the order in which the console logs are executed is correct. It's just that they're both waiting 2 seconds. Can you show the code once more?
Mm-hmm. Hang on a second. Like this?
Oh, wait. Oh, yeah, right. Yeah, because aren't you logging world first and then afterwards hello, which is what we want? Or do we want to wait for the timeout?
Well, yeah. I want to wait for the timeout.
Ah, okay.
Maybe I can make this. What about? It's just a silly example. Hello, friend. Something like that you want to do. Oh, it still makes sense. But you get the point. I just want to create a random example where you can write nice reading code without having too many callbacks, and you have some asynchronous things are going on here. All right, and we're going to promisify this code now and use async await. The standard example is, of course, we create the promise and promisify new timeout, because in timeout still using this was invented when I think promises weren't a thing. So a promise is an object which has this constructor, and it's accepting a callback, and the callback has to. So this is the callback here. First of all, it goes until here, and the specific of a callback is it has 2 arguments. These arguments themselves are functions, and these will be called. You can call these in your callback that you give to the promise constructor when you're finished with something. So resolve means everything was fine, and you can, for example, say resolve in the timeout with something, and then once the promise resolves, then your process will just run fine. If you call reach, and this will throw an error, which you can then handle or do something with it. The use case for that is, for example, you make an HTTP call, and if you get the HTTP call, and if, for example, connection is broken, you can call reject because the server wasn't reachable. If anything happens, then you can call reject. I hope that makes sense. So I'm going to copy paste the code. My timeout, it's the same thing here, just a different set of seconds. And I'm not saying console, but resolve. So this resolve refers to this thing here, right? So this is a function. The function is promise is expecting just these two, the signature, like two arguments. First one is resolve, second one is reject. And if we wait and resolve something, then we can wait for this promise. And we do it like this here, const resolved string or message, await my promise. All right. Now Node will tell me await is only valid in an async function. Now we come to async await, which is a recent addition to JavaScript to help to write better readable code. And I'm advising you to always use await and async. In order to use await, this must happen in an async function. And since I'm calling Node on this file, this is not inside an async function. So what I can do is to wrap basically everything in an async function, which is now an anonymous function. Oh. And I can, for example, call this function, and the process node will still be happy if I do that. So the await is now valid because it's inside this async function here. It goes until there. And I use parentheses, which is not a function call here, just a delimiter. And then call, with these parentheses, call this function. So when Node.js reads this file, it will immediately call the function. And of course, I should do something with the resolve message. Right? Hello, my friend, for example. So this is, first of all, how you can promisify a function. And yeah, and an async function will always return a promise. So if I define a function like this, async function, give it a name, some async function. And call the function. So what's going to happen? I think I will not see any console log statements.
But you are not calling the function yet, right?
Oh, yeah, of course. Thank you. And the Node.js process will finish immediately. I hope that's actually what's happening.
And you're not returning anything, right? That's what you're trying to say. Okay.
Yeah, let's remove that for now. Yeah. So as well, to make things easier, I can basically await anything. I can, for example, just await a string, and yet my async function will return a promise, right? Which you see here, and the promise is in pending state. In order to use the resolved message, the function that returns a promise, this would be actually equivalent to some saying, well, let's make two functions maybe. Shit, sorry. Some async function, return, await some message. Does it still work? Yes. This is like equivalent to writing a function, some function returning a promise, new promise, resolve some message. I should call this, of course. Not quite. So what did I miss? Can someone help me? Yuri, maybe? Okay, I'm confused myself. I just wanted to show how promises work and how to use async and await, and that an async function always returns a promise, and that you can use await only within the async function. But what I actually want to show you is how that relates now to GraphQL, because GraphQL waits for promises. If you return a promise in your resolver, then GraphQL will wait for the resolver to be resolved and then returns whatever the promise has for you. So just have to keep that in mind. And I'm going now into backend and, for example, create a new type, which is just called promise, which has an ID. And I'm going to create a query with returning promises of an array of promise, like this. Why not? And then have a resolver. Well, it's a little bit tacky, but move that for now. Return an array of new promise. There's, by the way, a shortcut, promise resolve. ID A. Maybe 3 is enough. B, C. That should work, I guess. What's the time? Oh, wow, 24 past. Shit. Hope I can show that to you. What's wrong? All right. Not authorized. Okay, let's just not apply middlewares. There we go. And in order to show you what I mean, you can also now implement a timeout. Solve. So I'm resolving this particular object, which is like the type which I want to return to the client, and I can say something like set timeout and give it like 1 second. That should work. Promise. Can someone help me right now? It's not an object.
Somebody's writing rapid in a lambda.
Yeah. Thank you. So I have a lambda call, resolve, and then this one. I'm a little bit lost now. Should have done this earlier. Promise, resolver. Okay, it's past 3. Shit. So what I wanted to do didn't work. I hope I can maybe do that next lecture. I wanted to show you actually that if you return a promise, maybe we should do this like this. What about that? I want my last attempt. So we have promises, which is returning new promise, resolve, reject, reject we don't need. And then we're calling resolve down here. That doesn't work. And now it's returning 1. I still need to return an array because I returned an array in my type resolvers, my type diffs. Ah, there we go. Fair enough. Okay, I'm saved. Okay, I'm now increasing the timeout, and you can see that that Apollo server indeed is waiting for 2 seconds, right? And if I do that multiple times, I don't know what I made, like how I messed this up. It's just the same thing. Now I have an array of promises, and I just do that. ID B. How is that different? Line number 8. No. Okay, where's the problem? Line number 13.
Yeah, maybe we should slowly start to wrap it up, Robert.
Yeah.
Also not sure whether, how many people it helps if we solve this issue now.
Yeah, I'm sorry. Maybe I should have prepared the demo code a little bit better. To wrap it up, what I wanted to show is that you can see the delay. So you have if you return a promise in your resolvers, then the resolver, you can return an array of promises, or you can return a single promise, which returns an array, which is slightly different because the single promise will wait for all promises to finish, whereas if you have an array of promises, then execution can fall through. So if you had like a chain of different resolvers and their type resolvers, then you can have multiple resolvers which return something, then call the type resolver which will have another, which will return another promise, and so on. And the apolloserver will wait and subsequently process these resolvers one by one, and then return, when all resolvers have finished, then return the final result. And the message that I want to give you here is that if you have a database call, for example, and your database call takes some time, then the execution of your single request to your apolloserver will increase the more complex it becomes. So if, I don't know, you have a promise which has nested promise, you do that, for example. What you can do is you can nest this promise all over again. And then it will, of course, wait for one promise to finish, then for the next one, and then for the next one. And if these promises are just replacement, or the example should show you if one of those resolvers is taking more time, for example, for a database call, then it's always best to have all the data in one go instead of multiple calls to the database, because you have basically n+1 problem for an apolloserver. Does that make sense? Like if you have a complex query and you have for every type resolver another promise which takes some time, that the entire execution will take longer. I hope that makes sense. All right, let's wrap up. 16 messages in the public chat. I think it's now time for questions. It's past. And
there are no questions in the chat so far.
Okay. Any questions related to authentication or authorization?
Questions to the homework, the next or to the last? Doesn't look like it.
Well, if there are no questions, then I would say we see each other in the exercise, in the seminar. No questions? There one person. Okay, thank you. Well, thank you for being here.
Okay, then maybe see each other in the group phase.
Nice. Okay, I'm gonna stop the recording now.